Okay, good morning, class. As promised, we're back. We're going to look at, we spoke about stem and leaf, group data. I think that's where we stopped. Okay, so now we're going to look at finding measures of dispersion or spread around the median. We're looking at the examples for exercise 13.6. Exercise 13.6 is on page 311. And we're reading the examples and the introduction starting on page 307. This is from the classroom mathematics textbook. Our textbook we're using at our school. No? Also, the full lessons can be found in the description box below. Alright, so measure of central tendency average. Averages are important since they can give us a picture of the group they represent. However, taken by themselves, they often give us limited view of the whole picture. Okay. The measure of how data is spread around the average is called measure of dispersion or measure of spread. Okay, this is some technical words there. We also need to know that the data are grouped around the measure of central tendency, whether the data are grouped together or whether the data is spread widely apart. The range is a simple measure of spread. However, it has its limitations. It cannot be used when the data is given in grouped frequency table. It is affected by outliers and can distort the measure. Okay, as we spoke many times before, that if something has outliers or values that's lying far from the data trend or the data set, okay, it will distort the measure. Alright, and then of course the median is the best measure of central tendency. It's affected by outliers and can distort this measure. An outlier that is very large or very small would give a misleading impression of the spread of data. And again, they gave us a note here that the range is the highest value or the largest value minus the smallest or the lowest value. Quartiles. People, if you hear quartiles, what does this remind us of? Quarters. Not so. And quarters is how much percent of the data? 25. So now we can look at data that is now divided into 25% intervals now, or categories. Okay. So if it talks about your first quartile will be from the smallest value to the first quartile. Okay. So what happens is we'll talk about the box and whisker now again. But this is normally your minimum value. This is quartile. So if we divide it, your data into quarters, then that's going to be 25% of the data. Can you see that? That's also 25%. That's also 25%. 25%. So how many quarters do we have? 4 quarters. Not so. And this first quarter is called quartile 1, quartile 2, quartile 3, and of course this is your maximum value. Can you see that, people? Now, quartile 2 is also what? What is also halfway to this data set? This point here. But your 50%, yes. Well, 50% is also what? Half, which is also what? Your median. Yes. Median, yes. So quartile 2, another word for your median is quartile 2. Can you see that, people? This is quartile 1, also known as the 25th percentile. Percentage is what? A representation of 100. So 25th percentile is the 25th percent. Yes. So quartile 1, 25th percentile or first quartile? It's all the same thing. Okay. Quartile 2, 50th percentile, also known as your median. So then this will be Q3, which is, what percentile would this be? 75th percentile or the third quartile. Quantile, quartile. Okay, quantile is something else. All right. So again, quartile 1 can also be called what? Quartile 1. 25% there or the first quartile. This actually, as one actually wanted to write lower quartile. That's what I wanted to actually write here. And this is because at the third quartile and Q3 is the same thing. No? So I wanted to actually have said here the upper quartile. Okay. Okay, guys, I have an idea now what's happening. No? Right. So let's take this off and see what they say. They definitely will say it much better than what I do. Okay. So let's go. Quartiles. The median divides an ordered set of data into two approximately equal parts, which is 50% on either side of your quartile. Not so. Quartile 2, your median. Approximately one half of this data set is less than the value of the median, and approximately one half of the data set is greater than the value of the median. So basically what they are saying there, that if you got the data set, you divide this data in half, that is quartile 2, sorry, your median. At this point you must know about quartile 2 yet. Your median. Okay, this is your lowest value and this is your maximum value or your highest value. That's all. So here they say the median divides the data set into two equal, so that's 50% there, 50%. Why? Because that is your median is your halfway mark. Not so. Right. Approximately one half of the data is less than the value of the median, and the other half is approximately 50% more than. Okay, this is approximation. Right. Right. Then we are told that it is possible to divide the data into further subdivisions. Okay, the third quartile, which is quartile 1, 2, and 3, divide the ordered data set into 4 approximately equal parts. As I said, if you're going to divide this out, you're going to get 25% there, 25%, 25%, 25%. Can you see that, people? So, what they said is, smallest value, lower quartile Q1. We also said the Q1 can be what? Quartile 1, lower quartile or 25th percentile. They didn't put that there, no? Median, Q2, or your 50th percentile is the same. Upper quartile, Q3, 75th percentile, largest value. Okay. You all with me then? Right. Are you walking around? Right. We are told that about 1/4 or 25% of the data falls on or below the first quartile. You see, sometimes that 25% that's on this line, on Q1. Not so, especially when the data is repeated all the mode is around this point. Okay. So that is why they are emphasizing is on or below. Okay, so 25% is neither on or below that. Okay. And about 3/4 or 75% of the data falls on or above quartile 1. So which means to say that 25% of the data is here, and then that's of course 75%. Can you see that, people? So that's that. Okay. Just carry on here. And then about half or 50% of the data falls on or below the second quartile. We know that already. And about 3/4 or 75% falls on or below quartile 3, and 25% is above quartile 3. So that is fairly simple. No? If you're going in this direction, that's 25, 25. So this is going to be 75% of the data, and that side is going to be 25. Of course, it's going to cover your 100%. Okay. So how much of the data is lying between quartile 1 and quartile 3? 50%. Can you see? 50% of the data approximately is lying between those two quartiles there as well. Okay. Right. So now we're talking about the interquartile range. So here we are told that note the interquartile range tells us by how much the data items in the middle portion of the data set varies. The interquartile range is the difference between the upper quartile, Q3, and the lower quartile, Q1. And that's exactly what I showed you here. That is Q3, and that's the difference between Q3 and Q1. So when you work out your interquartile range is simply going to be Q3 minus Q1. Alright? You guys understand? So just give me a minute. I'm just going to take the score quickly. I'm just going to pause here. Right, sorry about that. So, as we see, the interquartile range, also known as IQR, would be the difference between quartile 3 and quartile 1. And this tells us about 50% of the data that's basically in the middle. The nice part about that is it can tell you better about the data because the outliers is not affecting those values. Can you see that, people? So that tells you what's happening basically in the middle. So we say that your interquartile range is the difference between the upper quartile Q3 and the lower quartile Q1. The interquartile range is going to be known as that. So let's look at this example. This example is on page 308. Okay. This is on page 308. Here we are told that the X results out of 40 are listed for 15 learners. Okay, so number one, whenever I get this data like this, I put it in order. Okay, because that will be able to help us calculate the range, which is the highest minus the lowest. It will be able to help us calculate the median, which is the middle number. Also will help us with calculating Q1 and Q3, which then in turn you will be able to calculate the interquartile range. Okay. So let's put these numbers in order. What's the smallest number here? 7, 5. So it's 5, 7, 9, 10, 11, 13, 14, 15, 17, 16, 17, 18, 20, 21. There are two 16s. 21. There's 77. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16. Yes, I've accounted for all of them. So let's look at the range. No, I got this wrong. Because we have 15 values. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
There's only 116.
Now, who gave me 2 16s? The range, of course, the highest value minus the lowest value, 37 minus 5, which is 32. Let's look at B. So the B part of the question says find the median. So your median is the middle number of sorted data. Not so. Is this data sorted? Yes. How many values are you? 15. 15 divided by 2? Sorry? 7,5. So it's the 8th number. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's 15. So C number 1 says find the lower and upper quartile. So it's Q 1, your lower, and your upper is Q3. Q3 is also what can be known as your 75th percentile. So instead of asking Q3, the girl just hit 75th percentile. So what we do is, if there's an odd amount of numbers, there must one number in the middle. So to calculate your quartile 1 is the median of the lower set of data. So this we take out. Okay? Tomorrow I'll show you what happens if it's an even amount of numbers. Okay? So what we do is, we go 1, 2, 3, 4, 5, 6, 7. There's 7 numbers. What's 7 divided by 2? So it's the fourth number. So it's 1, 2, 3, 4. 10 is in the middle. Can you see that? So that is your Q1 is 10. You guys understand? So you count here. 1, 2, 3, 4. 1, 2, 3. So 18 is going to be your Q3. You guys understand? Then the question says, what does the measure tell us about the result of this test? So if you look at this here, what does this tell us? That 50% of the data lies approximately, approximately 50% of the data lies between or on 10 to 18. Can you see that, people? Then D1 says you must calculate your interquartile range. Okay? So your interquartile range is going to be Q3 minus Q1, which is 18 minus 10, which is 8. Now, what does this tell us about this data set? What does the interquartile range tell us about the data set? This tells us that the range, or 50% of the data, is spread over 8 units. You guys understand? 50% of the data is spread out over 8 units. Or the middle portion of the data. The middle 50%. Will you guys understand? So with that, you should be able to do for homework. Exercise 13.6. Number 1. Okay. Then we'll do number 1 and 2. Whatever you don't understand, we'll try and explain tomorrow. And we'll do the second example as well. People enjoy the rest of your day. Good morning, class.